Hey everyone, this is Eddie. I've been uploading some videos that are just quick time lapses of me building some amps. Some of you had questions on what exactly I'm doing, why I'm doing it, so what better time to introduce this series than part 7, I think, in the videos. So first of all, if you're not a subscriber, like and subscribe. If you're wondering what this microphone is, you can check out some of my earlier videos where I show how I built these DIY mics. This is the C12. And what we'll do today is I'll show you what the amp building series is all about. So the plan is to build 5 50-watt tube amps. I've built tube amps in the past. I've been doing this since about 2012 or so. And I've got one that I really liked. I got it dialed in. It's all turret board style, point to point. And it's kind of a rat's nest the way it got there. The tone's all there, but it's kind of messy on the inside. So what I wanted to do is kind of make a small run of amps, just 5, that are based off of that amp circuit, but a little bit well done with PCBs instead of hand wired throughout. So what I'm going to show you is the software I use, and this video is just going to go over how we made the schematic, did the PCB layout, and then ordered the boards, and then I can show you the boards that arrived from JLC PCB. So the first thing we'll go over is what type of software do I use. I use Easy EDA. It's free. They do have a paid version that has more features, but everything I need is good enough in the free version. The reason I use this is because it's nicely coupled to JLC PCB, which is who I use to manufacture. So between the two of those, it's really easy to find parts through their provider, which is pretty tightly linked to LCSC, which is kind of like the Chinese equivalent of Mauser or DigiKey. For every little part on this schematic, the resistors, capacitors, everything, I try to find to spec what's on the database in LCSC, and then I can pretty much just come over here to library, change my search engine to LCSC, and then from here I would type in that unique LCSC part number and then search and find that component. I try to find things that are, well in stock. I usually sort by the stock number to make sure I'm not building something that they don't even have the parts for. But yeah, with that, let's jump into it. So this is the schematic. I'm kind of zoomed out here so you can see everything. The signal flows left to right. We've got all the symbols for our little tubes, and then I just use the what are these guys called? I use the net ports for any switches or pots, because typically they're not going to have the exact type of CTS pots or alpha pots or three-way switches that I'm going to buy from them. I'll buy those from another amp supplier. So yeah, signal goes left to right here. At the end, I've got another little circuit that we'll cover at the end, which is something I'm going to try for the bias. But yeah, let's zoom in and take a look. So we can see that the input comes in here, and the first thing we're doing is we've got that 1 meg resistor to ground, and we're going through a 68K grid stopper to pin 7 of V1. The first triode of V1, pins 1, 2, 3, we're not using it, so I've got it as unused. Maybe if there's something cool I want to do, like another boost, we could add that in. But the type of amp that this is, it's already got a bunch of gain on tap. I can give you some background as to the style of amp that it is. So it's based off of Curt Mitchell's. He's the guy that did all the old VHS guitar instructional videos, and I think he still teaches somewhere. He's got a YouTube channel too. I'll link it down below. But yeah, Curt has an old Marshall that was modded by Todd Langner. Todd's no longer with us. I think he passed, but his mods are pretty legendary. He did a lot of work with extra gain stages on Marshall designs. I know he was involved with some of the ADA rack units that have tube preamps in there. I think he was involved with the Bogner Fish stuff too. So pretty legendary guy, known for high gain, but still really tight sounding amps. So this is my take on what I think is going on in Curt's Marshall. and I've sort of added switches so I can tweak it to the type of guitar, pickups, player, all that stuff. So yeah, with that said, we're essentially a 50 watt Marshall, but we've got an extra gain stage right at the front end there. So coming in, the input hits that first tube. We've got a 2.7K resistor in parallel with 3 different caps here that we can select, and I call that the low 3-way switch. So if we follow this equation, we can calculate our cutoff, our low cutoff switch, and these caps provide different cutoff frequencies which can kind of alter the tightness of the rest of the amp going down the line. So coming out of the plate pin 6 there at the top, we're going through a 22 nanofarad cap, and then from here we hit a voltage divider 470K over 68K, and if my math is right, that's about minus 18 dB. So we did a bunch of gain here, and then we're chopping it down again. And I've got a 3-way bright switch where the middle position is no bright switch, and then on the left or the right you can select your 2.2 nanofarad or 470 picofarad. Some of the values I put in here are pretty extreme, and that's for mostly high gain settings where we can get some real lift on that presence and some nice pick attack. So from there we're going to pins 1, 2, and 3 of V2, and here we just have a fixed 2.7K and 0.047 microfarad on the cathode. You'll notice the plate resistors here are pretty standard. We're just using 100Ks on all the plates. So nothing fancy going on that stage. We're just getting some gain and some extra filtering there with that bias point. And then we hit another 22 nanofarad cap, and we hit our first volume, which on the amp I call volume 2. And then that then goes into the third stage, which is the second triode of V2. From there, we do not have a bypass cap on the cathode. We're just doing a 4.7K. We still have the 100K plate resistor, and we have a slightly different 2.2 nanofarad cap coming off the plate to couple into the next stage. From there, we have another minus 18 dB volume with the 470K, 68K voltage divider, and we also have our second bright switch. So even though these bright switches are the same values, the fact that they're in different parts of the circuit really lend themselves to different like subtle tonal differences. Rarely would you ever really want to use both of those bright switches engaged. You could if you're going for something like super gnarly in the high end, but now you essentially give the player 4 different bright switch options, or they could leave both of those switches in the neutral position and just omit the bright switch entirely. So yeah, a lot of knobs to turn on this amp. From there, we go into the first triode of the third tube. These are all ECC 83 12AX7 tubes. I've got some of the Chinese ones from the Shugwang factory. Those are typically good at being, those are like good candidates for high gain amps. I'm not a fan of JJ's, and then for most clean stuff or like actual vintage Marshall layouts, I'll try and source some NOS Mollards or Phillips or RCA tubes. Those just have a certain character. But when we're dealing with high gain like this, right, we're not even at the phase inverter yet, and we're already through 1, 2, 3, 4 gain stages with a bunch of different bright caps. We typically want stable tubes, but tubes that do have a good bit of gain so that we can get the gain quickly and then tailor the volumes to the type of tone that we're after. So if I were to put like NOS Mollards in all of those positions, it would probably be pretty unstable. So the Chinese-made Shugwang ones are good for high gain amps there. All right, so this is pretty standard. We got our 820 and 4.7 UF. Pretty low cutoff there with the 4.7. We might take that out. I'm not sure yet. That's essentially like the fat cap position in other Marshalls. Same thing with the 100K plate resistor, pretty standard. We've got 33 UF, dual of them with a 10K smoothing cap, that pi filter up there on the voltage rail for V2 and V1, just to smooth out and get some better power supply rejection there. And then we go into the second triode of V3. We've got the 100K to ground. Most of this should look fairly standard for the Marshall stuff. So really only the special stuff is happening at the front of the amp, where we've got our extra gain stage, our low selector switch, and then our two bright switches there. But I'd say the bulk of the tone and what makes this amp do its thing is the unique cutoff that you pick here, along with that 2.7K on both of these stages. And then also the fact that this voltage divider is lopping off more volume than what you'd typically see in a Marshall. I think you'd typically see just a matched 470 kiloohms to get less of a volume drop. But the fact that we've got extra gain stages, we can take that volume hit because we're going to bring it back up again. So from here, we're at the tone stack, and it's pretty standard. We've got a 33K slope resistor, 500 picofarad for the treble, and then the matching 22 nanofarad for the bass and middle. I believe these pot values are pretty standard for like a Marshall design. The presence, we've got the variant where it's a linear taper 25K, and we've got that 4.7K coming off. Does that make that big of a difference compared to the other topology? I'm not sure. I mean, I've used both of them, and they're both pretty useful. It's not like one is less useful than the other. To me, the best thing on this presence was the fact that I've got these two caps working together to kind of dial in where that frequency boost is happening. All right, so from here we're pretty much bone stock. So we're coming out of the second volume, but I'm calling it volume 1. We go through that 22 nanofarads, and from here we hit a stock phase inverter topology. So the fourth 12AX7 in this amp is the phase inverter, and then from there everything else is pretty much stock. We're hitting our two power tubes here. We don't have a post phase inverter master volume. We do have those 22K, 220K resistors in there, just like a stock non-master volume. What's unique though is that we have our bias supplies separated, and this is totally untested, so it might not work, but what I'm trying to do is what's called the bug bias. So I will link down in the video. There's another channel, a really knowledgeable guy. He kind of goes over this bias design that he came up with, and he called it the bug bias. I think his company's Bug Amps, so hence the name. But what's cool about this is that it kind of totally gets rid of the crossover distortion that you'd have from an amplifier that's push-pull like this, AB, where one tube's doing one half and the other tube's doing the other half, and you've got that crossover point where, depending on the bias, you might have issues there. So I'm not sure if he's implemented this into, like a high gain guitar amp. I think he does more hi-fi amps. So it'll be interesting to see how this performs, and more importantly, how it sounds. Maybe some of the mojo of the original amp that I'm kind of basing this off of is that, lackluster Marshall bias supply that's kind of bare bones, and it gets the job done, but it's not, doesn't look perfect on the scope. So maybe some of the distortion I'm favoring is that power amp distortion. It'll be interesting to see. So anyways, we're at the end of this schematic layout, right? I call this the Ebony amp 50 watt. So fairly standard Marshall. We've just got some extra gain stage at the beginning and some extra switches so we can tonally shape the sound to the player, the guitar, the pickups. I guess I didn't cover here. We got our heaters. I'm planning on using the normal AC heaters, 6.3 volts. So these are just the heaters from my preamp tubes. I have done switch mode power supplies for rack units, stuff that's, more line level in, line level out. I'm pretty curious on if this all goes well and these turn out okay. One of the biggest cost items, and you'll see me working on them in earlier videos of this, were the transformers, right? Those big chunks of iron. So I would never get rid of the output transformer. That's in the signal path. That's probably integral to the sound. On my amp, it was the old classic tone output transformers. I think they're out of business now. There's a couple companies that try and replicate those transformers. The classic tone transformer was trying to replicate, an old Marshall transformer to begin with, so everybody's just copying everybody else. But it's really expensive to buy power transformers, right? So it'd be great if I could swap those out with a switch mode supply in the future. Sometimes switch mode scares people because they think it's not as good, but if you design it right and you've got all your feedback loops nice and tight and your switching frequency well above audio, it typically can help reduce size, weight, and power, right? And it'll even improve our noise floor. Getting that power supply noise well above the audio band is a good thing. So yeah, that's pretty much it for the schematic. Once I finish the schematic on a design and everything's good, you can go up to Easy EDA and you can hit this convert to schematic. That's not going to make your board for you. It's just going to kind of dump everything on a blank schematic so that you've got all your components there and everything's linked between the schematic and the PCB layout. That's a big benefit for any layout design software. Anytime I make a change in the schematic, I can just update it to the PCB layout and it'll swap out parts, it'll change trace names, so it's a good way to keep things linked, and you can do different revisions so you don't get lost in revision hell and you don't know what was working or what broke. So now we're going to jump over to the PCB layout. And there we go. I'll switch to the top layer. So what we're looking at here is essentially the board outline, which is in purple, purplish pink here. And I've placed all my components and I've routed all my traces and I've got everything, labeled so that it's easy to understand the circuit flow and where everything is. To be honest, it does not look like a typical hand-wired point-to-point board, so you lose that aspect of just looking at the board and knowing exactly where everything is going. But everything is kind of nice and tight, and it should help with keeping noise down. I do have ground planes on top and bottom, so this is a 2-layer board. And you can see that I route my traces, but then surrounding the trace on all sides is a ground pour. And then I do have some mounting holes that are also tied to chassis ground. I'm still learning the best practices for ground. From what I understand, it might not have been the best idea to link all of these mounting holes all to ground. A better practice might be only picking, one of them to go to ground. Because in reality, right, especially with shielded wire, that shield needs to eventually go to ground, but it's probably carrying a bunch of nasty things on there that you don't want to inject on ground near a sensitive part of the circuit, near like the input. So, but yeah, everything again goes left to right here. I've tried to lay the tubes out in a similar way that you'd actually see them on an amplifier. All your preamp tubes, V1, V2, V3, V4, the phase inverter, and then we've got our power tubes here, V5, V6. What else? We've got a lot of the bottom stuff here is that bug bias. That's got quite a few components hanging out there. For this, I'm not integrating any of the potentiometers or switches onto the board. I'm gonna hand solder wires to those guys there, so I've got sort of a row for all my controls and the bright switches up here. Everything is down on that side, so it's near where the front control panel is gonna be. And you'll see I've got 2 rat lines still hanging out on these guys. Those are my heater wirings, so that's 6.3 volts. Because that's AC and I want to do the twisted wire like a normal Marshall, I'm just going to do that on the underside of the board with some thick gauge wire, and that's why those aren't on the board as you see them. One thing I did take the time to do, you can see I kind of made my own little symbols down here on the silk screen, and those are on not only the top where the components get soldered into, but I've also got them on the bottom of the board so that either side of the board you're looking at, you'll know what component you're looking at and you'll know what it is, and that's also super helpful. So now I guess the best thing to do would actually look at the 3D CAD model of this so we can see how this would be delivered from the PCB manufacturer, in this case JLC PCB. So it doesn't look like a typical 50 watt point-to-point tube lamp layout, but we've got the tubes coming out of the bottom, so it's not like I don't have enough space here to put sockets, because those are actually going to come out the bottom there. So the top of the amp, it'll sit down like a normal Marshall. It's not going to be upside down like a Fender. So these are my 4 preamp tubes. They had models for those, so I just popped them in. And then I'll have different sockets for the power tubes. I haven't yet decided if I want to bolt those to the chassis and then run some wire down to those sockets, or if I want to actually put the socket on the PCB. Because I know when you go to PCB and you've got bigger mechanical components going into the PCB, over time there could be a crack in the solder joint from all those temperature cycles and moving it and all that stuff. So I'll try and find the best way to get everything bolted down so that it's pretty solid. But yeah, you can see from the top, if for some reason someone was looking at the top only, they can still find out where everything is if they have the schematic in hand. And then the bottom here, these are all the components that are going to be populated and soldered into the board from the factory, so they can actually do all this through-hole stuff. That's great for me because it means I don't have to do it, and if somebody wants an amp, I can order this relatively easily so long as all this is in stock. That said, there are a few components that end up where maybe I have a model in here right now, but it's not the part that I wanted to use. So for example, C16 and C23, if I don't want to use this funky cap from their factory and I want to use a silver mica cap or something, I can just omit that. It'll come to me blank, and then I can solder in the type of cap that I want. So with that in mind, let's look at what we got from the factory. So this is one of the boards. See if I can get it to focus there. And we can see they populated it with everything that we wanted. I'll try and upload some better pictures too, and you can see how there are some components that I swapped out with caps that I would rather use, like those black silver micas. I'm not going to go crazy and put mustard caps on every single coupling cap there. The original amp has some pretty nice parts in it, like mustards and the old Lemco dog bones and stuff like that. It looks like a proper Marshall in terms of parts. But what I'm really trying to do on this is, can I use modern day parts, a good PCB layout, and come up with an amp that sonically sounds just as good as that one, with maybe a little bit better noise floor since it's got the ground planes going on, and a better bias too. So hopefully this video explains some of what I'm doing. The earlier videos, I never intended people to watch them. They were just kind of quick time lapses, so I had a documented path of how I built the amps. But now that I know a couple people are interested, I'm going to go ahead and try and at least narrate over some of the videos and some of the steps that I'm doing. I'm pretty slow when it comes to working on these type of projects. I've got tons of other projects, so there's not going to be like a regular schedule. But I think I can maybe knock out an amp before the end of February, just the first amp, make sure everything works, the bias works, there's no thermal issues or noise issues. And that would be a pretty cool first test. Probably get a couple videos out of that. So next video in this series will probably be more metal work. I've got a lot of chassis holes to drill. I ordered the chassis just blank, and I'm still kind of figuring out where I want to put everything. I will probably make a faceplate. So in the earlier videos you saw me making some of the custom knobs, and those are some pretty massive, like 2-inch knobs, and I need 6 of them for 1 amp. So it's gonna not look anything like a traditional guitar amp. It's probably gonna look more like a big rack head that's mounted in a nice wooden cabinet. I've got a guy making some wooden cabinets for me because I don't do woodworking. I barely do metalworking, so that's why I'm struggling with drilling all the chassis holes. But yeah, should be a fun series. We should, at the end of it, have something that makes noise. Whether or not it's good noise, we'll find out. And thanks for watching. We'll see ya.